Two types of exponential behavior are exponential growth and exponential decay. First, consider the blue graph. It's an example of exponential growth. So as we move left to right on the graph, we begin with some very low output values. And as we move to the right, those values increase and increase more rapidly and increase more rapidly. And that's exponential growth. Exponential decay, shown here in orange, is similar, but shows a decrease in y values that decreases rapidly at first and then decreases more and more slowly. Note each of these, exponential growth and exponential decay, approach an asymptote. In this case, the asymptote is the x-axis. Recall that an asymptote is a line that a graph approaches, getting infinitely closer and closer to, but never quite reaching. Take note, concept summary, exponential functions. For the function y equals ab to the x power, if a is greater than 0 and b is greater than 1, the function represents exponential growth. If a is greater than 0 and b is between 0 and 1, so 0 less than b is less than 1, the function represents exponential decay. In either case, the y-intercept is 0, a. The domain is all real numbers. The asymptote is the line y equals 0. And the range is all y values greater than 0. Problem 2. Identifying exponential growth and decay. Identify each function or situation as an example of exponential growth or decay. What is the y-intercept? Part A, y equals 12 times 95 hundredths raised to the x power. Well, considering 0.95 in place of b, 0 is less than b, which is less than 1, the function represents exponential decay. The y-intercept, well, we know that's the point 0, a, and for us we have an a value of 12, so the point 0, 12. How about part B? Y equals 25 hundredths times 2 to the x power. In this case, b, 2, is greater than 1, so the function represents exponential growth. The y-intercept, the point 0, a, for us a is 0.25, so the y-intercept, 0, 0.25. Part C. You put $1,000 into a college savings account for 4 years. The account pays 5% interest annually. The amount of money in the bank grows by 5% annually. It represents exponential growth. The y-intercept is 1,000, which is the dollar value of the initial investment. We can also think of that as the savings account balance at time 0. Your turn, part A. Identify the function y equals 3 times 4 to the x power as an example of exponential growth or decay. What is the y-intercept? Part B. Identify the function y equals 11 times 0.75 to the x power as an example of exponential growth or decay. What is the y-intercept? And part C. You put $2,000 into a college savings account for 4 years. The account pays 6% interest annually. Is this situation an example of exponential growth or decay? What is the y-intercept?